Hello, I am Lucas Bailey.
And my name is Divas Tahal.
Today we're going to look at part one of our assignment two. So we were looking at the varying probabilities of tree density and how they affect the spread of forest fires that are caused by random lightning strikes. So we designed these forest models that have implementations of lightning. Um, a quick little recap of how it works is so we have these values P, which holds the probability of a tree growth in our model, and we assign the value P to then generate a random number between 0 and 1. And then we compare that random number to the assigned value P, so that produces the trees in our grid. And then we pretty much do the exact same thing for lightning strikes, where we assign a value to F and then generate a random number between 0 and 1 and then compare it to the value at F to denote whether a lightning will strike or not. Um, if lightning strikes the grid, there's a 50% chance that the lightning will actually catch fire. So in our model down here, we have two models. One model is trees are placed in the grid randomly, and the second model is that trees are placed in kind of clusters and they can only grow off of each other. They can't randomly spawn in the tree. But I will be talking about our random tree model here. So as you can see, we have this grid of trees that are randomly spawned, and we have these different values for the spawning speed of trees and then the lightning strike speed. So here, let me just run this first one. So as you can see, trees are randomly spawning into our grid. The red dots is when lightning strikes and actually catches fire. So it starts to burn all adjacent trees and kind of destroys the forest. And lightning can also strike and not catch fire. So that's represented as a blue dot. Sometimes they're harder to see, but let me play around with these p values. So if I change the growth of trees to be much faster, here we go. We can see that tree growth is a lot faster, and actually the screen becomes completely populated before lightning even strikes. Um, which is just basically saying that our trees are spawning in too quickly. So we can run another model here where we have lightning will strike at a way quicker rate. All right, so in this model we have lightning sped up. So yeah, as you can see, the red dots are the lightning actually catching fire, and then there's these little sporadic blue dots, which means that lightning has struck, but it doesn't actually catch the forest on fire. So as I said before, this is our model for random tree spawning, and we kind of want to compare that and kind of go back to our research question. How does the random lightning strikes affect the different tree growth? So I'm going to pass it off here to Dewis, who is going to talk about the cluster tree spawning.
Let me just pause that. But similar to the random tree generation, we created a cluster model where the trees are growing based off of each other. So a tree can only grow around its surroundings. And so this is another model that you can see there's a bunch of lightning striking on the ground. Listen, the black parts are just ground and the green parts of the tree. There's some fires, but there's some lightning as well. And you can see how the forest catches on fire, like on the random spaces, it burns off and the trees continues growing. Yeah, but basically that. And we could try with another model of zeros, let's do one. Tree growth and how fast they catch on fire. And we did this clustering model hoping that it would be a better representation of how actually forest growth is shown in real life. Because, no, right, let's see. I mean, the growth is a lot slower now. The lightning are still striking. This would probably be the best model representing how trees would actually grow in real life and how fires would catch to like random clusters of trees. Yeah, but we looked at the different models and different implementations, and we also looking at this, I mean, it's very clear that the fire will continuously spread until the whole cluster is dead, and that was our sort of the question that we were looking for. And this part was the most representative, and we do think that based on how fast the trees grows, there's higher chance of forest is burning down, and then there's lower chance when the trees are growing slower. So that was sort of our model, like CA model of the trees getting on fire. And talking about future work, we could probably also explore a lot of ideas. One idea that we were talking about was just having it so that the trees only grow after the forest is burnt. And then also in nature, there's a lot of factors that lead to forest fire, like wind, whether it's raining, and other stuff like that. So in future, if we have more time, we could probably work on those.
Yeah, so kind of like in conclusion to our research question of how do varying probabilities of tree density affect the spread of forest fires? Um, we kind of see that the when tree growth is accelerated, when the population of trees is more dense, uh, the the lightning actually has a higher chance of burning down the whole forest. Yeah, thank you.